Let's try this problem. An object is projected upwards with a 30-degree launch angle and an initial speed of 60 meters per second. For how many seconds will it be in the air? How far will it travel horizontally? Assume it returns to its original height. Let's make a quick sketch of the problem. We have an object that's being launched upwards. The speed is 60 meters per second. The launch angle is 30 degrees and it's going to follow a parabolic path. Let's first figure out the time it spends in air. If we focus our attention on the apex, we know its vertical velocity is 0. So we can use the Suat equation v equals u plus at on the vertical axis. The final velocity at the top is 0. In the initial vertical velocity, let's write that uy minus the acceleration points downwards and is negative, it's gt. So if we solve this for t, we get t equals uy over g. Uy is the vertical component of the initial launch velocity. So if this is our launch velocity, it's 30 degrees with the horizontal and this is 60. The vertical component would be 60 sine 30. So uy is 60 sine 30. Sine 30 is just half, so we get 60 times a half, which is 30. So we know uy equals 30, we can plug it over here. If we do that, we get time equals 30 over 9.8. Let's say it's 10, approximate that for simplicity, we get a time of 3 seconds. So it takes 3 seconds for the object to ascend. It's going to take 3 more seconds to fall back to its original height. That means the total time of flight, capital T, is 6 seconds. And that solves the first part of the problem. Let's move on to the next part. How far will it travel horizontally? How do we do this? We must realize that the horizontal velocity is given as 60 cosine 30. Since there is no horizontal acceleration, this velocity stays constant. The object moves at a constant horizontal speed of 60 cosine 30. For how long does it move? It's going to move for 6 seconds. Then what would be the distance it would cover? This is straightforward. The horizontal distance covered is the horizontal speed times the time it was moving, which is 6. So if we plug in the value of cosine 30, we get a value of about 311.8 meters. And that solves this problem. I hope you found this video helpful. I'll see you in the next one.